So for this lesson, we are going to be looking at solving equations by using the quadratic formula. So far we have talked about 3 other ways to solve, and that has been solving by factoring, solving by taking the square root, and solving by completing the square. So these are all methods that are faster are usually more preferred rather than using the quadratic formula. But I know if you are a person who does not get how to factor quickly, is not seeing the other methods that are useful, then you are going to struggle. And so this is going to be that failsafe. When the other methods are just too hard, or when you don't see a way, use the quadratic formula. So this is something you will need to memorize because I will not be putting it on the board for the test or any of the quizzes. So if you're going to plan on using it, you need to memorize it. So the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so you can pull all of these coefficients from that quadratic in standard form. You have to be in standard form. So let's go ahead and look at our first problem. So at the World Championship Pumpkin Chunking Contest, pumpkins are launched hundreds of yards. The path of a pumpkin can be modeled by h equals negative 16t squared plus 124.4t plus 42, where h is the height in feet and t is the number of seconds after launch. So we are going to use the quadratic formula to solve 0 equals, and we have that equation. So we are going to use the quadratic formula to solve this. So in this case, our A is that negative 16, our B is that 124.4, and our C is 42. So we're going to plug into that quadratic formula, and that is a negative B, so a negative 124.4 plus or minus the square root of 124.4 squared minus 4 times negative 16 times 42 all over 2 times a, which is negative 16. So then we are going to start simplifying. So we can't do anything with the negative 124.4, but we can with the 124 squared and the rest of what's underneath that radical. So 124.4 squared gives us 15,475.36. And then we have negative 4 times negative 16 times 42, and that gives us 2,688. That is all going to be over negative 32. So then we are going to add together what is underneath that radical. So that gives us 18,163.36, and that's still over negative 32. So then we are going to take the square root and that leaves us with negative 124.4 plus or minus, and then we just took the square root, which gave us 134, 0.77 over negative 32. So now we are going to have to split this up. And so we're going to have to take care of the positive case and the negative case. So I'm going to have negative 124.4 plus 134.77 over negative 32. And then we will have negative 124.4 minus 134.77 over negative 32. Now for the positive case, we're going to put all of this in the calculator and we get a negative 0.324. And then for the positive case, or the negative, sorry, we have negative 124.4 minus 134.77 divided by negative 32. And that gives us 8.10. So what do these two roots mean? So what they mean is that, remember, they represent t. So when our height is 0, it's at these two times. So since that negative 0.324 is, well, it's negative. Time cannot be negative. So negative 0.324 is not a valid answer. Because time after launch cannot be negative. And then that leaves us with 8.10 is valid. So the pumpkin will land 8.10 seconds after launch. All right, so now I want you to go ahead and try it. So you have a diver jumps from a diving platform that is 10 meters high. Her arc can be modeled by y equals negative 4.9x squared plus 2.5x plus 10, where y is her height in meters and t is time in seconds. So I want you to go ahead and use the quadratic formula to solve this equation, and then we will interpret the roots. So go ahead and pause the video and then hit play when you are done to see how you did. Okay, so we are going to first of all plug into our formula. So we have a negative b, so we have negative 2.5, and then plus or minus the square root of b squared, so that's 2.5 squared, minus 4 times negative 4.9 times c, which is 10, is all over 2 times negative 4.9. So we have negative 2.5 plus or minus, and then we're going to start simplifying. So 2.5 squared is going to give us 6.25, and then negative 4 times negative 4.9 times 10, that gives us 196. And that is all over 2 times negative 4.9, which is 9.8, and it's negative. So that's 6.5 plus 196, or 6.25. So that gives us negative 2.5 plus or minus the square root of 202.25 over negative 9.8. So we're going to take the square root. And then we are going to need to split it into two problems. So we have negative 2.5 plus 14.221 over negative 9.8. And then we have negative 2.5 minus 14.221 over negative 9.8. And so for our positive case, we'll put this in the calculator and we get negative 1.196. And then for the negative case, negative 2.5 minus 14.221 divided by negative 9.8. And that gets us see 1.706. And so when we interpret our roots, the diver is going to enter the water at 1.706 seconds because that negative is not going to be a valid option. Okay, so let's do some of these that are not in word problems, but we are going to still use our quadratic formula. So these should be a little bit easier to work through without the calculator, and we are going to get exact answers this time. So let's go ahead and look at example 3. So we technically have a 1 as A, B is 4, and C is negative 17. So we have negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 17 all over 2 times 1. So that's just going to be 2. So we're going to go ahead and start simplifying. So we have x equals negative 4 plus or minus the square root of 16. And then our negative 4 times 1 times negative 17 gives us 68. And that's over 2. And so then we have x equals negative 4 plus or minus, and then 68 plus 16 is going to give you the square root of 84 over 2. So we have negative 4 plus or minus, and then we're going to simplify the square root of 84. So for 84, we're going to see what we can divide it by. So we've got 2. That leaves us with 42, and then 2, and then 21, which goes into 3 and then 7. So we have a pair of 2's that will get to come out, and then 3 times 7 is 21. So we have 2 square roots of 21. Then we're going to go ahead and reduce everything by 2. So we will have negative 2 plus or minus the square root of 21. All right, so now I want you to go ahead and give this a try. So remember that 3 should be your A, and -5 should be your B, and 1 is your C. So go ahead and plug this into the quadratic formula. So pause the video, work this out, and then hit play to see how you did. So let's go ahead and take a look at this. So we should have a +5 because it's a minus a -5, plus or minus the square root of -5 squared minus 4 times 3 times -1 over 2 times 3. So we'll have 5 plus or minus the square root of 25 plus 12 over 6. So we'll have 5 plus or minus the square root of 37 over 6. And then there is no simplifying that you can do with this. So this is as far as it can go. So this is going to be our answer. So let's go ahead and look at example 5 so we can get a little bit more practice. We have A, B, and C. So we have -8 plus or minus the square root of 8 squared minus 4 times 5 times 11 all over 2 times 5. So we have -8 plus or minus the square root of 64 minus 220 over 10. So we have 64 minus 220. That is going to be -8 plus or minus the square root of -156 over 10. So then we need to simplify that square root of 156. So we're going to take 156, we're going to divide it by 2. That leaves us with 78. And then we are going to divide by 2 again. That leaves us with 39. That won't divide by 2, but it will by 3 and leaves us with 13. So we have a pair of 2's, and 3 and 13. We do need to also take out the negative. So we have -8 plus or minus 2i square root of 39 over 10. Now this will reduce by 2. So this will leave us with x equals -4 plus or minus I square roots of 39 over 5. All right, so now I want you to go ahead and give this next one a shot and see how it goes. So pause the video and see what you can do. Hit play again when you're finished to see how you did. All right, so we have 9 is A, -3 is B, 18 is C. So we are going to have -3, actually +3, plus or minus the square root of -3 squared minus 4 times 9 times 18 all over 2 times 9. So we have 3 plus or minus the square root of 9 minus, and see, -4 times 9 times 18 is -648 over 18. And then 9 minus 648. We have the square root of -639 over 18. So that's 639. We have, let's see, divide it by 3. That gives us 213. We're going to try to divide that by 3. That leaves us with 71. Now that will not divide by anything because it's prime. So we are going to take, let's see, 3 plus or minus, and then we're going to have a pair of 3's. So that gives us 3i square root of 71 over 18. This will all simplify by 3. So we'll have x equals 1 plus or minus I square root of 71 over 6. And this is where it will stay. All right, so let's go ahead and talk about using our discriminants. So in the quadratic formula, the discriminant is an expression under the radical sign b squared minus 4ac. So it's something you're actually already doing and already have been doing. So the value of the discriminant can be used to determine the number and type of roots of a quadratic equation. So if your discriminant is greater than 0 and it is a perfect square, then you will have 2 real and rational roots. So that means that they will look like 2 and 3, or it'll be like 1/3 and 1/2. So you'll have either perfect squares or you will have fractions. If b squared minus 4ac is greater than 0, but it is not a perfect square, you will have 2 real irrational roots. So it might be like 2 plus or minus the square root of 3, or it might be 1 plus or minus the square root of 7 over 5, something like that. But then if your discriminant is equal to 0, you have 1 real rational root because your parabola or your graph is actually on the x-axis. So it only crosses once, whereas in this other situation, you actually cross the x-axis twice. Then if your discriminant is less than 0, you have 2 complex roots, and so you have an I involved. So that will look like 1 plus or minus I square root of 3 over 8. So you will have an I in your answer. So for example 7 here, we are going to first of all find the discriminant for the equation, and then we're going to describe the number and type of roots for the equation. So we are going to still identify A, B, and C, but then we are only going to take care of the b squared minus 4ac. So we're going to look at negative 10 squared minus 4 times 2 times 7. So negative 10 squared is 100, and then that's going to be minus 56. So 100 minus 56 is 44. So this is a positive number, so our discriminant is positive, but it is not a perfect square. So we are going to have 2 real irrational roots. So now I want you to go ahead and try it on example 8. And so make sure you identify what everything is, and remember, we're just using what is underneath the radical. So go ahead and try this on your own. So pause the video and then hit play when you're done to see how you did. So A is 2, B is 8, C is also 8. So we are going to be using b squared, so 8 squared, minus 4 times 2 times 8. That gives us 64 minus 64. So that gives us 0. So the value of our discriminant is 0. And so there is 1 real root. And so then on example 9, we have A as -5, B as 10, and C as -15. So we're going to find the value of that discriminant. So we have, see, 10 squared minus 4 times -5 times -15. So we are going to have 100, let's see, plus, actually I don't think it's going to be plus, I think it's going to be negative because all three of these are negative. See, minus 300, yes, so that is going to give us a -200. So this is negative, meaning that we have two imaginary roots. All right, so for example 10, I want you to try this and give it a shot. So we're going to find the discriminant for 10 squared minus 4x plus 7 equals 0. So go ahead and pause the video one last time, work this out, and then hit play to check your answer. So A is 10, B is -4, C is 7. So we are going to have B squared, so -4 squared minus 4 times 10 times 7. So we have 16 minus 280. And so 16 minus 280 is -264. So our discriminant is negative, and that means that we have two imaginary roots.